Ever stop to think about what's actually inside that phone in your pocket? I mean, beyond the glass and metal. We know it's powerful tech, but what if the brains behind it, the actual chips, are being shaped not just by people, but by, well, by AI? Today, we're doing a deep dive into that very idea, how Apple, the company synonymous with slick hardware, is quietly using generative AI to help design its future chips. And we've got some pretty interesting insights here directly from Apple's hardware chief, Johny Srouji. It gives us a rare peek behind the curtain.
Yeah, it really does. And our goal today is to sort of unpack what this shift means for Apple's strategy, sure, but also for hardware development in general and, ultimately for the gadgets you use every day.
Okay, so let's kick things off with the big news, the things Srouji actually said, that Apple is now looking at generative AI for chip design. He mentioned, and I'm quoting here, generative AI techniques have a high potential in getting more design work in less time, and it can be a huge productivity boost. Okay, let's unpack that. What's the real story there?
Well, the significance is huge. Chip design complexity has just exploded, right?
Yeah.
Billions of transistors cacked onto tiny pieces of silicon. So the challenge isn't just making them powerful, it's designing them efficiently, reducing that design time, managing the sheer complexity that's paramount. And AI, especially generative AI, offers a way to maybe accelerate that. It can explore design possibilities, maybe even synthesize layouts way faster than humans alone. It helps coordinate the hardware and software teams too.
Right, it's not just crunching numbers, it's actually suggesting designs.
Potentially, yeah. Or at least automating huge chunks of the verification and layout process, freeing up engineers.
And Apple's been building its own chips for ages, haven't they? This isn't exactly new ground for them in terms of controlling the silicon.
Oh, definitely not. Remember the A4 chip back in the iPhone 4? That was 2010.
Wow, yeah. Feels like ancient history now.
It does. And since then, they've done custom chips for iPad, the Watch, Macs with Apple Silicon, even the Vision Pro. So they have this incredible history, this deep well of experience, and crucially, data about chip design. That's perfect training ground for AI models tailored to their specific needs.
Okay, so AI helping design the chips in our pockets. That makes sense. But here's where it gets maybe even more interesting. This other project, Adel, working with Broadcom, starting late last year on their first AI server chip. It's apparently called Baltra.
Exactly, Baltra. And this is different. This isn't for your iPhone. It's for Apple's own back-end infrastructure, their private cloud. Think about Apple Intelligence, their new AI features. Some stuff runs on your device for privacy, right?
Right.
But the really heavy lifting, the complex AI models that need serious power, those will likely run on servers in Apple's data centers. And that's where Baltra comes in.
So they're building their own server chips now, too. Why not just use existing ones?
Control. It's always about control with Apple, isn't it? Performance, security, how tightly it integrates with their whole private cloud compute strategy. By designing Baltra themselves, they can tailor it exactly for their AI workloads and maintain that privacy promise, keeping data anonymous and secure without needing user sign-ins for these back-end tasks. Give them a big edge.
That sounds ambitious. Building server chips is a whole different ballgame. It really speaks to that no backup plan philosophy Johny Srouji talked about.
It absolutely does. He brought up the Mac transition, moving away from Intel chips to their own Apple Silicon back in 2020.
Oh, yeah. That was a massive gamble at the time.
Huge. And Srouji literally said there was no backup plan. We went all in. That includes the hardware and a monumental software effort to make it work.
So you're saying that same all-in mindset applies here to trusting AI in the design process and even building these complex server chips?
I think so, yeah. It shows their willingness to bet big on controlling their core tech. They saw the payoff with Apple Silicon for Macs, and now they're applying that lesson further up the stack. They believe AI tools can make chip design faster, more precise, and they're willing to commit fully to that vision, just like they did with the Mac chips. It's about owning the entire pipeline.
What does that level of risk-taking mean for a company like Apple, though, taking these huge bets without a safety net?
Well, it means potentially massive rewards if they pull it off, like they did with the Mac. But of course, the stakes are incredibly high.
Okay, so they're going all in internally, but they still need partners, right? So Srouji mentioned that the EDA company.
Right, electronic design automation, companies like Synopsys and Cadence. You can design the world's best chip architecture, but you need sophisticated software tools to actually lay out the circuits, verify everything works.
And these EDA firms are Apple's suppliers for that software.
Exactly. Apple depends heavily on them. And interestingly, these EDA companies are also racing to integrate AI into their tools.
Ah, so it's AI helping build the tools that AI will then use to help design the chips. It's layers of AI.
Pretty much.
Mm.
Synopsys, for instance, has this thing called Agent Engineer. Think of it like specialized AI assistants for chip designers. They can automate really tedious, repetitive tasks, manage complex workflows, basically let the human engineers focus on the bigger picture, the more creative decisions.
Makes sense. Speed things up, reduce errors.
That's the goal. Cadence is doing similar things, expanding their AI tools. It's a competitive space because all the big tech companies want faster, cheaper ways to get these incredibly complex chips designed and built.
So looking ahead then, if Apple is integrating AI more deeply into design, what does that mean for, say, the kind of people they need to hire?
That's a great point. You need engineers who understand both hardware and machine learning now. People who can work alongside these AI tools effectively, who can guide them and interpret their outputs. It's a different skill set.
And does this change their relationship with partners? Like, they'll still use TSMC to actually make the chips, right?
Oh, almost certainly for manufacturing, yes. TSMC is the leader there. But the design work, that continues to move more and more in-house at Apple. And AI is clearly becoming a central pillar of that in-house design strategy. It reinforces that drive we talked about, controlling the entire stack, hardware, software, the services.
And now even the tools and processes used to design the hardware itself, plus the cloud infrastructure running the AI services.
Exactly. It's about tightening that control over every single layer of the technology.
So let's bring it back to the listener. We've covered quite a bit. AI helping design Apple chips, this whole Baltra server chip thing, the no backup plan attitude, the role of ETA partners. What's the big takeaway for someone just using their iPhone or Mac every day?
Well, think about this. If AI is increasingly involved in designing the core silicon and powering the cloud services behind the scenes, what could that unlock? Could we see innovation speed up even faster? Will devices become capable of things we haven't even imagined yet because the design process itself is evolving so rapidly? And how does this full stack control from the AI designing the chip to the chip itself to the software to the AI cloud service change the game? It's something to really ponder how deeply integrated that entire ecosystem could become.
It definitely gives you a new perspective on the engineering packed into these devices. It's not just circuits anymore. It's circuits increasingly designed with intelligence. Fascinating stuff.